Welcome to the Middleware Tech YouTube channel. In this series, you'll learn about functional interface. All code examples used in the videos will be available on GitHub. Let's get started.
Functional interface. Fine. Okay, so what is this functional interface? So main purpose is, let me talk about the first point about functional interface is that so it is used to invoke Lambda expression. First point I want to say, it is used to invoke Lambda expression. So first point is this, that the purpose of using Lambda functional interface is in Java is that I can call a Lambda expression using functional interface. Fine. But before that, you should know that what is the definition of functional interface in Java 8. We know till Java 7 we have the interface concept, and we talked about the properties of interface, right? We talked about the properties of interface here. So we know what are the properties of interface, but we don't know what are the properties of functional interface. Let's talk about the properties of functional interface. Functional interface and our normal interface both are different. You cannot say the normal interface till Java 7 is a functional interface. No, we have a separate definition for functional interface. So what is that? Let me give some of the example of functional interface, some of the example functional interface type in our normal Java class, normal Java APIs. You may have heard some of the interfaces, pre-built interfaces like runnable. You may have heard, right? When you're going to create a thread class you can create implementing a runnable interface to support the concept of multiple inheritance in case of thread programming. You may have another one class that is called compatible. Compatible is one type of interface that is used in collection to make or to implement sorting of object inside a collection can use this compatible. Similarly, comparator is another one. Is there comparator? Similar type of interface is action listener. If you see, these interfaces are already predefined interfaces in Java. If you go into this interfaces structure, API documentation, you'll find that all these interfaces contain a single abstract method. If you go into runnable, you'll find one method, run method is there, that is a single abstract method. If you go to compatible interface, it contains a particular method called comparator. You find one of the you'll find one method, compare method is there. In comparator, if you go, or in action listener interfaces, you go, that in all of them, one method is there only. These are all interfaces, right? Predefined interfaces. But if you go inside this interface, you'll find that only one abstract method is there. You have to remember that any interface that have a single abstract method is called a functional interface. First point we say is that any interface any interface that contain a single abstract method. Any interface that contain a single abstract method is called a functional interface. So how it is, how it look like. Let me give a small example. Let me give one small example, like right here, like I'm writing here, public interface hello world. So if you see, this is an interface, simple Java interface, right? Simple Java interface. So simple Java interface only. Now this interface, I'm going to write one method here. Just see here, void abstract hello. So what we find is that we have one abstract method inside this interface. So just now I told you that any interface that have a single abstract method, it is called a functional interface. This is the functional interface definition in Java 8. Okay. Now, another one parameter is there that I can use an annotation like functional interface to declare an interface as functional interface. Again, I'm saying I can use an annotation at the rate functional interface to declare an interface as functional interface. So this annotation I can use, but its use is optional. That means I have to use at that functional interface. It is not mandatory. But if you use this, then it will say that whether you are using functional interface or normal Java interface. Let me see. What I'm doing is that I'm creating an interface here. What I'm doing, I'm creating a functional interface. So right click new interface. I'm going to create a functional interface. So this functional interface name is function, or sorry, hello world. Hello world. This is my functional interface name, hello world. No main method, simple functional interface we have created. So is it a functional interface? So what I want to do is that let me just copy this code, right click copy, right click paste. I've created an interface like this. So what it is saying, just see here, it is saying that hello world is not a functional interface. I have used at the functional interface annotation, save public abstract void, set return type to void. Okay, save it. I have used a particular signature like this. Fine. Now what I want to do is that let me write another one method. Control V, and see the method name is hello one. Just see here. Just save it. Now if you see this, it is saying that it is giving an error. It is saying that at that functional interface annotation, hello world is not a functional interface. Why? Because inside this interface I have two methods. Already you know that abstract, public and abstract, by default interface methods are by default public and abstract. So if it is not a functional interface because I have two abstract method inside the interface. Who is saying this? this annotation. If you just remove it, you will not get any error. It will count it as a simple Java interface till Java 7 what you find. So it is not a functional interface. So how to identify this hello world is a functional interface? Now hello world is a functional interface that is identified by that the interface must have only one public and abstract method. And you can define this annotation, you can declare, but its use is optional. What the purpose of this annotation is that if you have more than one method, then it will tell that you have not created functional interface. Same like you use that annotation at that override, right? If you have not overridden properly, then it will give some error. Similarly, same like that at that functional interface annotation will give an error if you are not using the property like you should have or you must have only one public abstract method inside the functional interface. So if you just remove it, that error will go, and now it will be counted as functional interface that have only one public abstract method. Fine.
This is Anshu. I have one question.
Yes,
So
please.
this functional interface is Java 8 feature.
Yes, that is the Java 8 features.
Okay.
It was
Okay,
not there
okay.
before Java 8. Yeah.
We have functions which we have interfaces which have a single method,
Yes,
but now
yes.
this @ functional interface is only a Java 8 feature.
Yes,
and we are
that
writing
concept came from Java 8 features because we can use this at to call Lambda expression. So I'm coming into that.
Yeah, okay. Oh, okay, thank you.
Yeah, fine. Now this is I'm talking about. I'm just going to define this functional interface concept. This is the parameters. Okay. Now this functional interface is user defined. Yes, I have created only this hello world function interface just now I have created, right? It is an user defined. Fine. Now just see here. I'm writing some code. Just see here, please. This is my user defined function interface. I'm writing here public class. Some class I have creating that has a main method, public static void main. Yes, the string. Here it is. This is my main method. This is my user defined class. HC is my own user defined class. And inside this user defined class, I have a main method, right? Okay. Now what I'm going to do is that, let's see here, I'm going to create an anonymous class object. What I'm going to do, I'm going to create an anonymous class object. So remember what I've told you, anonymous class object is that I can create an anonymous class object overriding the method of some other class or interface or abstract class. Again, I'm saying how to create an anonymous class object. I can create an anonymous class object. I can create an anonymous class object overriding the method of some other class or interface or abstract class. So here I'm going to create an anonymous class object, new hello world. What I'm doing, I'm creating an anonymous class object, new hello world. Now here, opening brace, closing brace, semicolon. Okay. Now here, so what I've done, I've created an anonymous class object overriding the method of this interface. Hello. So I'm overriding this method here. Control V. And you can just write this method as public void hello. I'm overriding the method, right? So when I'm going to override, I should have a strong or equal access specifier. By default, that was public. So I am also using public here, and I'm going to override this method from here with my own code. So just write here inside, something like that. System dot out dot println, and just write here inside and right. Fine. So this is what? This is an anonymous class object. Yes, this is an anonymous class object. Now, till the time you're not going to point out with a particular reference, no use of this object, right? So what I want to do is that I want to point out this with a particular reference. So Control C, Control V, just give some reference as obj equal to new hello world, like this, right? It should be like this, right? Okay. So this is my anonymous class object. This anonymous class object I'm going to point out with the help of this reference obj. So what I'm going to do here is that now how I can call this function? Then just inside this main method you have to write obj dot hello. If you call obj dot hello, then you're calling the functionality that is available inside the anonymous class object. Yes, it's correct. Yes. So let me check it's working or not. So this code, just converting it like this, Control C, hc.java. So for the time being, let me just close this, right click, tail it. I'm going to create a class, right click, new class, hc.java, hc.java. And here I'm going to paste the complete code. Control V, save it. And this is my function interface. This is an interface. Save this. This is my class. Right click, source format, save it. And if you execute it, it will work fine. There is no issues. It is working fine because you have created an anonymous class object. Create an anonymous class object. I'm calling that method that is declared inside an anonymous class object, creating a reference or handle that is going to point out, right? So obj.hello, it's working fine. Fine. So this code is working fine, no issues. Fine. Now already I told you that Lambda and what this is functional interface. The purpose of functional interface in Java is, in Java 8, is to call Lambda expression. That is the only one purpose. That's why functional interface concept came. So where is Lambda expression here? What we will do is that if you see this syntax, what is Lambda expression I told you? Lambda expression I told you, no method name, no return type, no access specifier. Lambda expression is always defined using this symbol. Left side should be input, right side should be output. If I have only one syntax, only one line, that curly brace is also not required. This is how this Lambda expression look like. Right now, this Lambda expression is the anonymous class object function interface is used to call this Lambda expression. That's it. And just write here obj dot hello. So if you see the syntax in this example, we have created our own functional interface. This is our Lambda expression. This Lambda expression I'm calling, creating a reference of functional interface, and using that reference I'm calling hello. So when I'm calling this hello method, calling obj.hello, then this code gets executed and it will print inside no. To see here, let me just copy this code, Control C, and paste it here, Control V. So if you see this code, right click, source, format. So if you see this code here is like that, we have functional interface, and using this functional interface reference, I'm calling this Lambda expression, and I'm calling obj.hello. That time this Lambda expression gets executed, and you will get the output. So this Lambda expression, left side is input, right side is an output. There is no input. There is no input. And I'm creating a point out this Lambda expression is already told you that Lambda expression is nothing but an anonymous function. Now this reference is pointing out to this, and I'm calling obj.hello. I'm calling obj.hello. Hello is a method, abstract method declared inside a function interface, and that has no parameter. Hello has no parameter. So when passing hello that has no parameter, it is going to call this Lambda expression that has no input parameter, and it's going to print the value inside no. So this is the first example where we are calling a Lambda expression, creating an object of, creating a reference of functional interface. When I'm calling obj.hello method, hello is an abstract method. Calling this hello method that has no input. Input is not there. If input is not there, so automatically the output gets executed and it is printing inside no. Right? So this is the first approach we talk about how I can call a Lambda expression using functional interface reference. But we should know some more example using this type. This is the where this functional interface is also predefined. And this Lambda expressions also, we have created our own Lambda expression to print something. Already I told you, right, how to convert Lambda expression from a particular method. Now, the thing is that the functional interface that we have created is okay, fine, but in Java 8, okay, in Java 8, we have lots of predefined functional interfaces. In Java 8, we have lots of predefined functional interfaces that we should understand. Let me open API documentation, go to we should understand with some more example, then things will be much more clear. So what I'm going to do is that I'm going to do Java 8 API doc. So if you go to Java 8 API documentation, you'll find one of the package for functional interfaces. Okay, there is no concept of module, right? Module concept came from Java 9. So in Java 8, you can go to a particular package called java.util.function. Java. Where to find this here? Java.util.function. Yes. If you go inside this package, java.util.function, you'll find lots of predefined functional interfaces. See here, lots of predefined functional interfaces are there. Predicate, consumer, function, by predicate, by consumer, by function. These are all predefined functional interfaces. Okay, so the question is that we should know about them. As for example, this is one of the functional interface. Okay, and so right, so like this we'll find lots of function interface. Function is one of the function interface. Right, so I'm coming into those things only. What I'm saying here is that we talked about functional interfaces. This is the definition of functional interfaces, and this is how we can call a lambda expression using functional interface. But we need to understand this with some more example. What I'm saying is that yes, let me complete some portion, then I'll come with the question answer, huh? Because lots of the things will be done in between. So just see here, I'm talking about that functional interface, and I'm saying that there is some predefined functional interfaces. Number 5, talking about predefined functional interface. So what are the predefined functional interfaces are there in Java? Like we have consumer, we have predicate, then we have function. These are the predefined functional interfaces. Similarly we have supplier. These are similarly we have control C. We have some other functional interfaces like control V, like we have by predicate, by function, okay, and by consumer. Fine. Now the thing is that to understand this functional interface and lambda expression to the most detailed way, because how I can use them in our day-to-day programming in Java 8, we should know about these predefined functional interfaces first and how to work with them. How to use this predefined functional interfaces to call a lambda expression. In which scenario I can use them. Why they are the very important part in Java 8 to write very less and concise code. So we should understand about them in details first. So you'll get a very good idea on this functional interfaces and its use. Okay, so let's understand this functional interfaces one by one to get some more understanding on them. So first functional interface I want to use that is you can use this predicate itself. Let's understand one functional interface. Let's use predicate, okay, or take it function as you wish. Let me take it function first. In this example, we have created our own functional interfaces, user-defined functional interfaces, and we have seen how to call a lambda expression. Now I'm talking about a predefined functional interface, that is function. So this function is a predefined functional interface. Okay, this is called function. So So let's understand about this predefined function interface first, right? Okay, just give me 1 minute. Okay. Now, where I'll get details about this predefined function interface function, check API documentation. You'll find here on predefined function interface called function. This is what it is. Function. Yes, this is the predefined function interface. So this function interface is defined inside a package called java.util.function package. So first point, if I want to say about it, that it is defined inside this package, java.util.function.start in this package. It is defined. Now to understand this function interface, predefined function interface called function, let's understand the basic Java coding first, because directly I don't want to implement that. Let's understand the basic Java coding first before saying anything else here. Let's see, I'm going to create a class. Class name is addition. So it's a simple Java class I'm going to write. And inside this, you can create a static method, public static int add. Fine. So int a, I'm going to, this is going to add some number or multiply some number as you wish. If you want multiplication or a square, or you can use calculation. Multiplication, I use the class name as calculation. So this is the simple class is there, and we have a particular multiplication method, mul, static method it is. And what it is doing is that it's going to return return a into a, like that I want to do. Fine. Now how to call this function from the main method? I'm going to call this function from the main method. I can use main method, public static void main. You can write here, string RGS. Fine. Now inside this, I'm going to create an object. See, a static method, right? So static method I can call directly. Our main method, static method is in the same class. Our main method is there, so I can call directly this method. And if you write 9, then it's going to return that multiplication method, and you're just going to print system dot out dot println. It is just going to print the multiplication. It's correct one, right? It is, we generally do it in normal Java. Now what I want to do is that I want to convert this implementation using function interface and Lambda expression. Okay, so how it is? So just see here. So what I'm going to do, just see here. Same function I'm going to copy and pasting once again here. Control Z. Control V. Same function I have written 2 times. Fine. Now here, what is lambda expression? What lambda expression is saying to us? Lambda expression is saying that no function name, no return type, no modifier. This is how a lambda expression look like. Left side is input, right side is output. In case of lambda expression, data type is also not required. Input will enter automatically. If you have curly brace, return is mandatory. If you don't have curly brace, return is optional. So you can remove return also. So you can see here complete method how I have converted the lambda expression. Left side I have only one parameter, so that's why this bracket is also optional. So the complete method, if you see here, the complete method you have converted as a lambda expression. Complete method we have converted as a lambda expression here. Correct? Fine. This is my lambda expression. Now I'm talking about this lambda expression is used to call, now see, I'm talking about the functional interface, its name is function. I'm talking about the functional interface, its name is function. Remember, this we have some properties for this function. What is this function? Interface properties function. What is the property? Is that when I should use this predefined functional interface function. It's predefined. So when I go for this predefined functional interface named function, F capital C. So we'll go for this when we have some input. Then it will perform some logic. And return result. If this is the scenario, that time I should go for a function interface named function. What it is saying, take some input, perform some logic, and return result. Yes, it is taking some input, perform some logic, and returning this result. So this is the condition for implementing functional interface named function. And these 3 conditions matched. Take some input, left side is input. Perform some logic, yes. And return some result because it is returning. So this is the function interface. So this function interface, I have to call using this function f equal to like this. So it should be, let me just put in the same line like this. Now this is like this. Now here you have to see one point is that I'm using functional interface. If is a value and at a equal this, so this is my input inside the function. This is my output from the function. Now how I'm calling this function interface have some inbuilt method. I already told you that if you have a function interface that have a public and abstract method. So let me check this function interface. You'll find there abstract method and only one abstract method that is called apply. Already told you that functional interface must have only one abstract method. This is my abstract method, apply. Now what I'm going to do, I have to call here if dot apply. I'm calling if dot apply. This apply method is taking some argument. What is the argument? This argument is nothing but the argument of your input. So if I'm going to write here 5, that means it is taking this 5 input and returning 25. If I'm going to write here 9, that means it is going to take 9 input and returning 81. Right? So I'm using this function interface reference. I'm calling the apply method. Apply is a predefined method. It's a predefined method. And it can take only one argument. So if your method is taking only one argument, then only you can use this apply method for your function. Now here, if you see this function interface, you can get some more details about this, that it is taking 2 arguments, T and R, 2 parameters there in the if you see here V, if you see here, if you see into this function interface of V and R. So V the type of input to the before function, right? And right, okay. So here you can use for this first integer is type of input and the next integer is type of output. Okay, so if you execute this, just save it, calculation.java, and let me execute Control C. This part not required, directly I'm using this. So my class name is calculation.java. So right click new class. Class name is calculation.java. Control V. Save it. Now this function is a part of, I have to import that package. Import java.util.function.star. Right, like this. Save it. Right click, run as our application. And you can see it is output is 81 and it is working fine. The same code you can execute in Java where I have to write 2-3 lines of code more. And that line of code I can reduce with the help of functional interface function I've used to call the Lambda expression, and it is working fine. If you remember that when I'm going to pop some input, that input will come inside the Lambda expression left side. The output of this function will be Lambda expression right side, giving the output, and it is going to print that output, and that is coming as an 81. Right. So this is about this is all about this function interface function. So it is one type of predefined function interface that is declared inside this package. When I go for this, there is already I told you lots of function interfaces there. Out of that, we'll talk about only 6, 7 to 8 function interface in our example. So when I should go for this function interface function is that when I'll take some input, perform some logic, and return some result. Fine? Yes, fine. Anyone have any question till now?
The two integers there, right? I missed that part. We were function inside.
Which one? Tell me. This one you're
I
saying?
mean, we are calling. Yeah, exactly.
Okay. So what we say here is that we are going to use the functional interface called function. Function is a predefined functional interface. So what we have done here is that we have created a reference of functional interface function. So already I told you that functional interface is used to point out or used to invoke Lambda expression. Yes, we are invoking Lambda expression. Fine. So this is a predefined functional interface. So whatever it is, predefined functional interface or user-defined functional interface that have a public and abstract method. Single public and abstract method. Yes, I have a single public and abstract method called apply. So when I'm passing some parameter, this apply method will take some argument. You see here, this apply method will take some argument. So if I'm going to pass some parameter, so the result of this apply method is this. Input inside this apply method is this. Again, I'm saying this apply method is taking some input, right? What type of input it is? Integer type. So first integer is saying that the input is integer type inside the apply method. Second integer is saying that the output of this apply method is integer type. Fine. I'm calling Lambda expression. Lambda expression, already you have to remember that. Yes, please.
Yeah, Amit, one point I'm just asking here in that last that system.out.println f.apply. The apply is the method that will be overridden by this function interface f.apply.
You can say yes, because it's a predefined predefined method inside the function. Yeah.
Okay. Another thing is, can we use the so whatever that is in the inside the function? There is an integer means the wrappers are there. So can we directly use the wrappers inside that wrapper classes like integer and integer?
No. Just remember that I know it's a wrapper class. That's fine.
Okay.
So we have to remember this is that when I'm going, this is a generics, right? So when I'm going,
that is correct.
Yeah. Yes, we can use this one like this, right? This is a normal approach. When I'm going to use parameter, I can use wrapper class like this. And this is an approach for, don't think about that it's a separate, don't separate it as a wrapper class because, you know, in Java 5 version, right, we have one, this is an int, I got your point. This is also int is a primitive type. So in Java 5 already one features, right, that primitive type automatically boxed inside a wrapper class object called autoboxing, or that is called autoboxing, right? So in this example, autoboxing will come in by default. So this is a general approach. It's for any method you can declare like that. It's Japan approach because your method should never return primitive. It should always return some class object. So if your method is returning and primitive data type int, so it is recommended that always you should return a wrapper class object.
Okay.
Right?
No, ma'am, I'm asking in
yes, please. One by one, please. Yeah.
I'm asking in that perspective, like in Java, it means something they have added a new thing, or it is already there. In that perspective, I'm asking.
Same concept.
Okay. Thanks.
Yeah.
So is it must to define this generic? If we don't define, will it give error or it will?
Oh, no, as you know, I got your point. As you know that generics we should always use from Java 5 version. It is recommended that you should give. If you're not providing the generics, it will give some warning. I don't want this warning. Let's see here. It will give some warning. See? But it's coming. See here, it's coming some yellow. right? But as you know that from Java 5 itself that we should always use generic, so we should always
It
go
is
with that.
giving error, not warning, it was giving error.
So if I'm going to remove this, it is giving an error that we should always provide this. Yes, we should always provide this because we should
It
always
is
use this
must to provide
generics.
generic.
We
Okay.
have to use this generics.
But what we know it for generics, it is recommended only, not must to provide. But
No,
here it is
it
must
is.
as.
Yeah, fine, but from it's a general approach, you know, from Java 5 itself is that we should always use generics when you are writing some Java code, either in collection or JDBC, everywhere. So based on that point of view, it is also comes with this only, right? Yes, please. Any other things anyone want to add? Till now, whatever we talked about. We talked about basic interface concept, then we talked about anonymous class, then we talked about function interface, only one user-defined interface, function interface, and only one predefined interface we talked about function. So any questions from anyone till now, whatever we have done? Fine. So what we'll do next is that what is recommended in Java 8 that we should familiar ourselves the use of these functional interfaces. We should know how to use other functional interfaces, some of them, because already you know that lots of functional interfaces is there in this same package. But some of the functional interfaces like supply, predicate, consumer, and supplier. This we should know through hands-on because they are going to repeat the same thing. I'll tell you, but we should know about these functional interfaces, how to work with them, and we should use them in our day-to-day programming also. Right. So so what we'll do is that we'll take some break for 15 minutes, 20 minutes, and then we'll start. Anything else anyone want to add? And you can do some other task also in between. Fine, guys. Anything else anyone want to say? We'll take a break. For now, it is as we have told that 1:30 to 3:30. We'll take a break, 10 to 15 minutes. Now it is. We'll start exactly at about 4 o'clock. Yes, guys. Anything else? Or we'll complete another one function interface, as you say. Let's talk about predicate also. Let's complete this, then we'll go for a break. So this is the function interface. Its name is predicate. And this function interface is also defined inside a package. Name of the package is java.util.function. Right? And this predicate, now see here, function is used when I have some input, perform some logic, and it is going to return some result. If this is the scenario, then I'll go for this function. Now when I'll go for this predicate come into picture when your method is going to return some Boolean value. Okay, the same things will be there. Control C. Same things will be there. Same things will be there. Now this predicate will come into picture when it is going to return some Boolean value. Fine. So take an example like that where your code is going to return some Boolean value. So I can take some code like take some code like odd even code, you know. So we have one public class, okay, like to odd even number. I think we can define it very well. This odd even number, this contain some, how to define odd even number. So you can write public string, okay, and get num type, okay. Now here you can define like let's say you are going to take some input parameter int I, okay. So if for the logic that I modulus 2 equal to 0, right, then it's going to return even, right? Okay. Else it is going to return some string called odd, something like that. So this is just what type of number you have written. Based on that, is going to give the return type. And in the main method, you can provide public static void main string edges. So what I can do is that I have to get an object of this odd even. Obj equal to new odd even. And then what I'm going to do, I'm calling here obj dot get num type. So here I can pass a particular number called 9, 7, 8, something like that. So it is going to return me odd or even, right? So that I have to print here system dot out dot println, and that's it. It should print. Now, if you see this example, this is an example where your method is returning a boolean. Your method is returning a boolean value. So you can return a boolean value here. So you can write here true or return false. So like this way you can write. So if it's returning a boolean value, then that scenario. So in that case, you know, we can go for this function interface called predicate, where it will take some input. Yes. It is going to perform some logic. Yes. And then it's going to return some boolean value. So if this is the scenario, then I should go for this predicate interface, predicate functional interface. So this is the best fit. So now the question is that already talked about that if it is a functional interface, then it should have a predefined abstract method. Fine. So we'll go to check this predicate function interface. You can see here predicate. If you see here, this is the predicate. And if you go inside this predicate, you'll find an abstract method is there. Its name is test. Fine. So the question is that how I can convert this using Lambda expression. Same like that. I'm just going to write it once again. Control C. Control V. So same like earlier, I should not have a return type, no method name, no return type, no modifier. This is the symbol of lambda expression. Yes. In the left side, I have only one argument. In case of lambda expression, it is automatically identify the input. That's a no data type. And only one argument. So this is also not required. In the right side, what it is returning in the right side is returning a Boolean value. I'm just returning this Boolean value manually like this. But if you see, this expression is itself returning a Boolean value. This expression itself. So you don't have to manual return like this. This expression itself will be returning Boolean value. If it is 0, then true, else it return false. So itself it is returning Boolean value. So this is my lambda expression. That's it. Where the left side is an input, right side is an output. What is this? It's a Boolean value. So this is my lambda expression. Fine. Now I have to call this lambda expression. How? Using, I have to call this lambda expression using function interface. I have to call this lambda expression using function interface called predicate. I'm just putting them in the same line. I have to call this function interface using predicate. So in that case, what I can do is that not required. Just write this lambda expression, Control V, and I have to call it using predicate. Predicate. Fine. So predicate P equal to this. Okay.
Sorry to annoy you.
Yes.
What time could we have a break?
Oh, just 2 minutes. We'll take a break now only.
Okay, thank you.
Just 2 minutes, yeah. Now here, you're going to use predicate P equal to this. Okay. Now, what I told you that this predicate P out this is declared. See in the API documentation. This is the predicate interface. It is taking only one argument. Okay. Now it is integer, so I can use this one argument as integer. Fine. Now predicate is using one predefined function. Name of the function is test. See here, name of the function is test. It is taking one argument. So I can use here p dot test. Okay, it is taking one argument. So what should the input argument? Input argument should be this one. Yes. So assume the input argument is 9. So this input argument is your input argument in your lambda expression left side of this symbol. So this is your input argument. So once you have given, this is the output argument. So what output it will come? True or false, whatever it is based on the input. So it is a Boolean value, correct? So it is going to return that Boolean value, whatever the output will come. Let me check. We are calling a predefined function that is called test. Okay, so let me check here. Control C, odd even. So I'm going to create another one class, right click, new class, I'm writing odd even, and this is my method assume, and this is my class control V. So you can see here, I'm going to use a predicate function interface. So import java dot util dot function dot star. Let's save it here, and this is a semicolon, right? And just save this, right click, source, format. It's fine, so there's no error, right? And what we see here, the complete code replaced with this 2 line of code, where I'm going to check whether a particular number is odd or even, and that I've replaced with just 2 lines of code. How? I'm using this predicate functional interface, and this has an inbuilt method called test. What I want to check, whether a particular number is odd or even. So the number I have given here, assume I'm using a particular number called 19. I want to check whether this number is odd or even. So this is my input. Okay, let me check. Right click, run as Java application. So when I've given this input, so that input will come inside the Lambda expression left side. That means here the output will be this side. So this side gets executed. I modulus t equal to 0. It is not true. So that's why it is a false. That means what? It is not an even number. It's an odd number. So like this way, you know, we can use predicate functional interface to call a Lambda expression. And what is the advantage is that I don't have to write this much of code. Not required, right? So that is being replaced by just a single line of code. So what happened is that I can write very less and concise code with the help of functional interface that is used to call Lambda expression, right? And you can write very less and concise code, right? It's a good example, right? As we have done last time function, this is a good example when I can use predicate. But there is some condition. Condition is that yes, you can use this function interface only when your method argument is 1. If you have 2 arguments, I'll come into that. There is some other function interface for that. Fine. Yes, guys. Anything else anyone want to add from here?
Yeah, to use this functional interface, one thing we should know the name of the class, and secondly the function that is
Yes.
going to call.
That will
So
come with
both are
That will come with practice. As you know what are the properties of abstract class interface, same like that it will also come. You may find first time it is slight different, but with practice things will come. First time you may find it different.
okay.
Okay. So what we'll do is that we'll take some break for 10 to 15 minutes or 20 minutes, and then we'll move next.
Okay, one quick question.
Yes, please.
Not regarding the subject. Do we need to mark any attendance?
No, you don't have to mark any attendance here because since you have logged in, so automatically it will come in the circuit. Okay.
Okay.
So who have logged in the
assessment will be
circuit? No assessment is not there. Just you have to attend. That's it. Your attendance will be done based on once you have logged in the circuit. Automatically, your attendance is over there. Though some of you will take separately, not required. It will come automatically.
Fine, I'm done. This is just today's class, right? We can finish right tomorrow on there is no session, right?
No. Only for one day. This is.
Okay. Oh, fine. Okay, thank you.
Okay. Yeah. So fine, guys. We'll take a break for 15 minutes or 20 minutes. Then we'll start.
Sure.
Okay. So okay guys, let's start after break, and next we'll talk about the other predefined functional interfaces that we can use. So let me share my desktop. So before break, if you see here, we'll talk about 2 functional interfaces. One is predicate. This is one. Another is function. This is one. Just we talked about these two functional interfaces before break. Right? Fine. So next we'll talk about another one functional interface that is called consumer. So let's understand about this. Consumer. Now this is also another one functional interface that is also defined inside the same package called java.util.function.star. Same package we can define. Now if you remember, a function interface is generally used when we'll take some input, execute some logic, right, and return some result. That time function interface generally used. Whereas predicate interface is used when I'm going to take some input, perform some condition check, and return some Boolean value. So when I go for consumer function interface, so it is actually used when it will take some input and perform operation and does not return anything. Does not return anything. Okay, that time we generally go for this consumer functional interface. So what does it mean by this? So let me check first what are the abstract method inside the consumer interface, consumer functional interface. So if you check in the left side, this is the consumer functional interface, and it has a specific abstract method. Its name is accept. So accept perform this operation on the given argument. So we have one of the method inside this that is called abstract. Right, fine. So if you want to write the full signature, then it will be void accept. So as you can see that this function will take a particular argument and perform some operation. Now the thing is that in case of consumer, it does not return anything. What does it mean? Is like, let's understand with an example better. So assume I have one class and the class name is EMP. Okay, this is an EMP class. Now inside this EMP class, we have one instance variable inside this EMP class as a string EMP name. An instance variable inside this EMP class. And I have one constructor. So this is my constructor. And here I can write a string name. And this is my constructor, how it look like. And what is the purpose of this constructor? Is going to initialize the name, right? So you can write parameterize constructor this dot emp name equal to name, like this. So it's a simple Java class that has one parameterized constructor and one instance variable, as you find. right? Okay. Now, now let me write one main class here. And then one class I can write like consumer test, something like that. I can use some name. Consumer test. Some name as you wish. So inside the class, I should have one main method. Fine. So public static void main. This is a string here, JS. Fine. Now inside this main method, what I want to do is like, see, I'm not going to write the same things. Still now what we are doing is that first I'm writing some Java method, right? And then I'm converting as an Lambda expression, right? So you got it, right? If I have a Lambda expression, that means the actual special symbol left side is an input, right side is an output. That we already got based on our discussion till now. So I'm going to write a Lambda expression here. That Lambda expression left side is an input. Input means I want to give an input of EMP object. Right side, what I want it should print some name of that EMP. Okay, so how it will print Lambda expression already you know, right? You want to print the name of an employee, system dot out dot println. It is going to print the name of an employee. So I can write e dot get MP name. So this should be the getters, right? We should have a getters also here. We have not written getters and setters. Fine. Now, if you see here, this is a Lambda expression. Left side is an input. I'm going to pass an MP object, and this is going to print an MP object name, right? So, so assume we can just write here something plus some parameter like one st first, something like that. Fine. Now this is my Lambda expression. This is the Lambda expression. Now who is going to call this Lambda expression? I'm going to call this Lambda expression using function interface. The name of the function interface is consumer in this case. So consumer, at the name is saying that consumer will always accept EMP object as an argument and process it, right? So we want all the EMP object should execute simultaneously. Okay, so in that case, how I can do it is that I cannot write here consumer E1 equal to like this. Okay, now consumer is an interface. Fine. So what are the argument for consumer interface? You can check. It's going to take one argument T. So assume for our case, it is going to take an employee object called EMP. Okay, so it will take a particular argument. So how I can give the argument? We have predefined method called accept. You can see predefined method called accept. So using accept, it will take an argument. So if you want it to take some argument using accept, so you can write here like, you can just write here obj dot accept or e1 dot accept, e1 dot accept. Now here I have to say some points. E1 dot accept, this will take some argument. Just see here, argument is e1. So here I have to do some changes because I've not yet talked about what I want to say. see, as you make it a C1. See, when you go for this consumer, is that we want some EMP object or some department object or some product object should get executed simultaneously. Okay, and all the three consumer object is ready to be executed as we call the chained consumer. Okay, so for this what I have to do is that first assume this is my first consumer C1. I'm going to this is going to consume first employee object and going to print the employee name. Control C. Assume this is the second consumer object and this name is C2. Okay, and it is going to print the employee second consumer object name, then third consumer object. So I have total three consumer object here, C1, C2 and C3. Okay, and is going to print the third one, 3RD. So in all the three scenario, it is going to consume some EMP object and going to print the name of the employee. Fine. So I have total three consumer object. When I go for this consumer will go that it is going to consume some EMP object and is going to return, not going to return any output. So how I can implement that one? So in that case, you can do like here and create another one EMP consumer object. Control V. This is an example. You can do it in differently. I'm creating an consumer CC. Okay. And I'm calling here not like this. You can call here like C1. Okay. Dot and then we have one function called and then. You can see here. We have one function called and then. It is used to simultaneously execute multiple objects. And then I want to execute C2. Okay. Dot and then this is a function name. Okay, and then I want to execute C3. So if this is the requirement where I want to execute multiple objects simultaneously, okay, that time I should go for this consumer interface. Now here I'm not initialized any name, right? So EMP E1 equal to new EMP. So this is my employee object we have created with a particular name. You can use since we have this parameterized constructor. Let's see, the name is Srinivas. Fine. So this is my employee object. It's okay. I've consumed three consumers because I want to consume three EMP objects simultaneously. I've created a consumer object CC. Now what I want to do is that I'm calling cc.accept. cc.accept because accept is your public and abstract method. Accept. So in the accept, I am passing some parameter E1. So E1 is the argument inside my accept method. So that means in your Lambda expression, left side is the input, right side it is going to print the name of the employee. Correct. So assume for the timing this is not there. Only one is there. Correct. So you can use C1. Let me check how it comes. Just close this. Class name is consumer test.java. Control C, and we'll come to our this class. Just write consumer test.java. So right click, new class. Class name is consumer test. Okay, and this is your main method. Okay, now here Control V, file save, and if you execute, and if you see here, this is a consumer, the function interface, so you have to import it. Import java.util.function.star. Okay, fine. So this is my EMP class. So if it is an EMP class, so I should have getters and setters. So save it, right click, source, getters and setters for EMP name. So right click, source, format. Okay, so this is my EMP class. And here we have the consumer test, and the consumer test, I am creating a 3 consumer object, E1, E2, E3. Both consumer reference is going, function interface reference is used to call the functional Lambda expression. Now here what we have done is that in this example, one object is calling to another object simultaneously like this, and I'm passing the name of the employee object is Srinivas, and I'm calling this accept. So if I execute, right click, run a Java application. So when I write like this, what does it mean is that so this is my accept input, right? So this input will be the left side of the Lambda expression, and right side of the Lambda expression is going to print something. Yes. So that is the thing, in this scenario, it is not going to return anything. It is not going to return anything. It is going to consume the object. If the requirement is that where I have to consume multiple objects simultaneously, so it is going to take some input, all right, and do some operations and consume the corresponding object without returning some output. It's not returning anything. It's going to consume and printing some value. So if this is a requirement, when you want some function to consume, you're not going to return anything else, then we should go for this consumer function interface. As you see here, it represents an operation that accepts a single input argument, return no result. Unlike most of the other function interfaces, consumer is expected to operate same like that, right? So the thing is that this type of function we generally go when this type of requirement is there. Plus it has another one facility is that if multiple object I want to call simultaneously, then also you can call it using consumer, because it is, see here, it is given one of the function called and then function. So it returns a composed consumer that perform a sequence, this operation followed by after the operation, right? So this is one of the scenario that I can say, fine. Okay, similarly, we have another one function interface, its name is supplier. We have another one function interface that is called supplier. Now, what does it mean by supplier? I'm coming into that. Now, it is also, we can define, it is also defined into the package called java.util.function. Now, this supply interface is also dot star. Supply interface is also defined in our function interfaces. You can see where is supplier. This is my supplier. And if you see, it should have only one public abstract method. The name of the corresponding method is get. It is going to return some result, right? So we have one method inside this supplier function interface. Its name is get method. Is it taking any input? See here, get method is taking input. No, it is not taking any input. See here, get method has no argument. So it is not taking input, just returning some output. So that is the scenario when you should go for this supplier interface is that it is not going to take any input. See the scenario we talked about earlier, right? This is the scenario for a consumer. It will take input, perform operation, does not return anything. Then just see here for predict, take some input, perform logic, return Boolean value. Now see here for function, take some input, perform logic, return result. So the thing is that in case of current scenario, it is not going to take no input. Okay, so let's copy this one only. In case of function supplier interface, what it will do is that just make this number 3. Number 3 as it is, that no input. So you have to use here in case of supplier. You have to remember that if my function is not taking any input, okay, if the function is not taking any input, is going to perform some logic and going to return some result. That type of scenario I'll go for supplier. Okay, so is there any example like that? Let me give one example like you can take some example like let's see what it is saying. It is not taking any input and returning some output. So you can define a particular lambda expression like this, right? It is not taking any input. So lambda expression I can define. No input. How to define lambda expression? This is my symbol. No input. No input means what? If this is the symbol, no input means what? I can use like this, no input. It is going to return some output. So it is going to return on the right side something. So what we'll do is that you can use some number. It should return like math.random. Okay, it's going to return some number. Correct, fine. So this is a lambda expression. It's a lambda expression. And I want to call this lambda expression. I want to use the functional interface is supplier. Why? Because no input. Then supplier is the best one. Fine. So supplier I have used. Just check what is the supplier signature. Supplier is going to take some value here, T. So it is nothing but not an input. It is actually a return type argument. So here I can use double. T is a type, right? So I can use a double. Fine. So I can use some RV, some return value or something like that. So this is my lambda expression. This is my lambda expression. This lambda expression is going to return something. What type of value is going to return? Double type. So how it will work? It will work only when you call the abstract method of your supplier. What is the abstract method of supplier? rv.get. This is the abstract method of supplier. Correct. So it is going to print the double value. How to print it? System.out.println. Right. So it should print like that. Like this. Right. So this is the scenario. One of the scenarios. This is an example where we generally use supplier. Is that when I don't have when a method should not take any input parameter and it is going to return something. If this is the scenario, then I should go for this functional interface called supplier like this, right? So let's see how I can execute it. So you can write one class called supplier test, right click new class, and class name is supplier test. This is my main method. And here inside this, Control V, enter, file save. So to import this supplier is a part of Java detailed function. The line should end with a semicolon and save it. So right click source format. That's it, right? It should work. Let me check it's working or not. Run as Java application. Yes, it is returning some random number that gets printed. It's not taking any input, right? So this is one of the scenario when I should go for supplier. So we talked about total 4 scenario. Function, predicate, supplier, and the consumer. Similarly, we have some other classes also. If you see here, by predicate, by function, by consumer, right? So we should know about these functions also. So we got that same concept. Concept is same, whatever you have done for function, predicate, and consumer. By supplier is not there, only this 3 is there. So what we have done in case of predicate, if I have some Boolean value going to return, then I go for predicate based on one input. Now, when I should go for this by predicate? By predicate also is used if it is going to return a Boolean value based on some input. By function is also going to use when you're going to take, it is going to get some return based on some input. By consumer is also used, it is going to return based on some input. But in this case, what you know, predicate, let me just write what is the predicate. This is the function. Control C. This is the function. This for function. Some input, perform logic, return result. Here also, some input, perform logic, return Boolean. Here are some consumer, some input, perform logic, return, no return. Return nothing. Something like that. So this is the same logic I have put, right, for predicate, function, and consumer. What is the difference between predicate and by predicate? Difference is that it is going to take 2 input. Last time I taken only 1 input, it is going to take 2 input. So similarly for by function also, it is going to take 2 input. Similarly for by consumer also, it is going to take 2 input. This is the point. This is the only difference. Rest of the thing is same only. Okay. So let's take an example. If it is like this, let's take an example, because now I'm going to write all the things once again. Directly I'm writing. Okay. Very simple examples are there and that you can use. If you want to use by predicate, check it first. What is by predicate? Just check by predicate. So by predicate, what it is going to take is that abstract method. Just check this abstract method. See here, it is going to take 2 input. Right? Rest of the thing is same. I'm not going to say. So the function is test. Correct. Okay, so if I'm going to write the same code for predicate, I'm just writing here. Okay, how it will be look like. You can write by function, by predicate, right? Predicate, by predicate is going to take 2 input. So 2 input for the time I'm using for integer. You can change it to double, float as you wish. Integer. Okay. Now some value bi equal to now I'm going to get a lambda expression, right? So this is my lambda expression. Yes. The left side of the lambda expression is going to take some input. Right side of the lambda expression is going to give some output. So the left side of the lambda expression is going to take some input. So how to define the input? Define the input, take some value like x, comma, y. Two input is going to take. Yes. And the right side is going to give some output, whatever output it is. Remember predicate. Predicate. If I'm using predicate, output should be Boolean value. If I'm using predicate, output should be Boolean value. Correct. So I can write something like that. X greater than y. It is going to return Boolean value. Yes, it's correct. Going to return Boolean value based on the input. Yes, it's correct. So how it will can execute this lambda expression? How I can execute? I can write pi dot what is the method name? Test. Bi dot test. Yes, and pass some parameter like 6, comma 3. So what happens? 6 is greater than 3. So it is going to return a Boolean value. So if I'm going to take the input, so input will come on the left side of the lambda expression. Okay, so then the route side will get executed. See, always remember this is an input to the function, then output of the function. So what it is going to check is that 6 greater than 3 is going to return Boolean value true. So it is going to print the Boolean value true. That's it. Same like earlier only, you know. So the difference is that it's going to take 2 arguments. Difference is that it's going to take 2 arguments. Same like if I'm going to take function. If I'm going to take function. So function means what? 2 input, perform logic, return output. Find 2 input. 2 input. So I have the function interface for function is called by function. By function. Fine. I have to check the parameter. Some value equal to what it is. By function is going to take check what is the inbuilt function for by function. Check by function. What is the inbuilt function for by function? Inbuilt abstract method for by function is apply. It is going to take 2 arguments. So right, so I can write here bi dot apply. It is going to take, sorry, it is going to take 2 parameters, like let's say 20, comma 25. So so this parameter is an input to your lambda expression. This is an input to your lambda expression, right? So let's see, I'm going to write an lambda expression here. So input to the lambda expression, that is left side, and take some parameter here called num1, comma num2. Okay, and on the right side we should have some result. Some you can print result or not required, you can directly just print the value. Num1 plus num2 semicolon. So if this is my input in the this is my output, the addition between the 2 number. Correct. So 2 argument is there, right? So 2 arguments here. Now here 3 argument will come into picture. 2 argument is an input argument. 1 argument is your return type. 3 argument is there. So assume the return type is of a string type. You can do it like this, right? In Java. Result. You can concatenate this string with this like this. You can do. So right, fine. So here we have 3 argument is there. See here in your function, if you see 2 argument is going to take. Yes, I'm passing two argument only. I'm passing two argument only. But it's going to return another one argument. So three argument I have to provide a type here. Here. So first argument, input argument is integer type. Second input argument, that is also integer type. And third is the return type, output argument. The output argument is what type? After addition, I'm concatenating with the result. So output type should be string type. Yes, they can write a string. That's it. So this is a good example how I can define by function. Right, it is going to return some result. Difference is that you're going to take two input. Fine. So same like this, we can define by consumer also. Okay. So as you find by consumer is returning nothing. So you have to take some example where it is not going to return anything. So it's by consumer, right? So let's take some example. So let me create some object first for by consumer. So by consumer BC equal to, I have to provide some lambda expression. What is the inbuilt method? BC dot, let me check what are the inbuilt method for by consumer. Inbuilt method for by consumer. Yes, it is accept. Inbuilt method for by consumer is accept. Like this. That is on right. Inbuilt method for by consumer. Let me check once again. Inbuilt method for by consumer is accept. That is going to take two argument. That is going to take two argument. Correct. So same, the concept is same only. I'm not going to execute once again. The concept is same only, right? So you can get the idea, right? Same like that. You have to go for some other function interfaces, like you can see int binary operator, int consumer, int function, int predicate, int supplier. So you can go with this API documentation and go. I can explore on thing. So I'm not going into more than this from here. So what we find is that we can, in this our discussion is that we can write lambda expression, and using lambda expression I can write very less and concise code. So to call lambda expression we need functional interface. That functional interface concept came from Java. In case of functional interface we must have minimum only one public and abstract method. Now this functional interface we can create by our own. That is user defined functional interface, or if I can use the functional interface that's already defined inside util.function package in Java. So it is recommended that we should use this functional interface in our code. Purpose is to reduce code or number of lines of code. Best approach is to use different functional interface to call lambda expression. Correct. Okay, so next